Alright, consider the following question, the first one. Determine the inductive reactance, that is XL. You are looking for XL. I will know XL to be 2 by FL. When 3 millihenry, so that 30 millihenry is L, but the unit is Henry, so that milli is over 1000. So when you divide 30 by 1000, you get 0.03. So it means L is given to be 0.03 Henry. With a negligible resistance, is connected to a 1.3 times 10⁻³ Hertz oscillator. So an oscillator produces what? Alternating what? Current. So in that case, we are given frequency F to be equals to 1.3 times 10⁻³ Hertz. So our aim is to get XL, and XL equals to 2 pi. The F is 1.3 times 10⁻³, and our L is 0.03. By the time you multiply everything, we'll get our answer. So that should be 245 ohms. Next, in the curve, PQRST represents an alternating voltage of frequency 50 Hz. So we are given frequency to be 50 Hz. So what's the question? The time interval between P and R is, this P, this R. So this is actually half of a period, because a complete cycle starts from here and ends here. So this is period. So if this one is period, this is actually what? Half of a period. That's period over 2. So we are given frequency, recall, period equals to 1 over frequency. Then it means the period is 1 over 50. What are you looking for? The time interval there is T over 2. And that's what? 1 over 50 over 2. That is 1 over 100, 0.01. The time interval is 0.01 seconds. Next, an alternating source is connected in series to a capacitor of reactance, that's XL. XL is 10⁻³ ohms. And resistor of resistance, that's R, 10⁻³ ohms. The impedance is, in this case, we have only X and R. There is no what? C. So that's what? Impedance for RL circuits. And during the class, I already given the formula to be R squared plus XL squared. So our ZRL equals to the square root of R is 10⁻³ all squared. XL is 10⁻³ root 3 all squared. I believe you can finish by yourself, but let's continue. So this becomes 10⁻⁶ plus, if you square root 3, that will be 3 times 10⁻⁶. 10⁻⁶ is common, and if you square root 10⁻⁶, you get 10⁻³. Or let me just separate inside so you'll not be confused. 10⁻⁶ into 1 plus 3. Because I can write as 10⁻⁶ times 1, that one is common. Sorry, that one will remain. So this time around, square root of 10⁻⁶. Square root means half, so half of 6 is 3. So as Z becomes 10⁻³ times 1 plus 3 is 4, root 4 is 2. So the impedance becomes 2000 ohms, or 2 times 10⁻³ ohms. That is the impedance. For the next one, the power dissipated in an AC circuit with RMS current of 5 amperes and RMS voltage of 10 volts and phase angle of 60, that's 5, is what? Recall, formula for power dissipated is what? IV cos phi. Is there in your notes? So what is I? 5. What is V? 10. Then cos phi 60. Cos 60 is half of 10 is 5, 5 times 5, 25. Then the power dissipated is what? 25 watts. Next, the voltage of the domestic supply is represented by this. Determine the frequency of the supply. This is for instantaneous voltage. And what's the general formula? Vt equals to what? V naught sine 2 pi ft. So if you compare, The maximum voltage is 311, but that's not our concern. Our concern is to get what? T. If you check, what we have beside T here is what? 3.142, 314.2. Beside T, we have 2 pi f. So if you compare both, it means 2 pi f equals to 314.2. So this is 2 times pi is what? 3.142 f equals to 314.2. So if you divide this by 3.142, this one the sheet we have 1 here, 1, 1, 2, 3. That's equals 100, 100 over 250. So just divide both sides by this. At the end, you get frequency to 50 Hz. Do it out by yourself. Next, what is the resonance frequency in the circuit? What is the formula for resonance frequency? The resonance frequency is equals to what? 1 over, 2 pi root LC. So the L is 8 milli. Milli is what? 10 to the power of 3 minus 3 rather. So from here, resonance frequency becomes 1 over 2 pi root. What is L? 8 milli. Milli is 10 to the minus 3. And C, 15 micro. 15 microfarad. Micro is what? 10 to the power of what? Minus 6. From here, the resonance frequency becomes 1 over 2 pi root. So if you do 8 times 15, you will get 120. Then this with this, you add the power, that's times 10 to the power -9. Okay, this equals to, I can write it as 12 times 10. Then 10 to the power of 1. 1 minus 8 is 1 minus 9 is minus 8. So this also is taken as 1 over 2 pi root 12 times 10 to the power -8. Now square root of 10 to the minus 8 is, I will divide 8 by 2. That is 10 to the minus 4. If I take it up, that will be 10 to the power 4. So up I'll be having what? This becomes 10 to the power 4 over, I still have 2 pi below here, root 12. So 10 to the power 4 is 10,000 over 2 pi times root 12 is square root of 4 times 3, that's 2 root 3. 2 root 3. So you can finish up by yourself. So 2 times 2 is 4, divided down by 4, then I'll be having pi and root 3. So you can, look for what we call the conjugate of the base. That's solved. You can finish that yourself. That's mathematics. Lastly, in the circuit below, the PD across the inductor is 8, and that across the resistor is 6. Find the effective voltage. Recall, the formula for the effective voltage V is square root of VR squared plus what? VL minus VC squared. But this time around, you have only what? L and R. So C will go away. So it means the effective voltage becomes square root of VR squared plus VL squared. So our V becomes square root of, what is VR? VR is 6 squared. Then VL is 8 squared. You finish this, you should get your V to be 10 volts. Alright, for the next set of question. In a series RLC circuit at resonance, look at resonance. The voltages across the resistor and the inductor is 30 and 40. It means VR is 30 volts and VL is 40 volts. So what's the question? What is the voltage across the capacitor? We're looking for VC. This question is extremely simple, but if you don't note this, you might get it wrong. Note, at resonance, one of the conditions we check, I gave you 8 conditions during the class, is that VL equals to VC. For resonance to occur, it means the PD across the inductor must be equal to the PD across the capacitor. Since the PD across the inductor is 40, it implies that the PD across the capacitor, which is what we are looking for, will also be 40 volts. As simple as that. Next, the current through a resistor in an AC circuit is given by this. So AC current IT is what? 2 sine omega t. Question, determine the DC equivalent current. Note, when I started lecture, I told you IDC equals to IRMS. So in short, you are looking for the RMS. And what's IRMS? I naught over root 2. What's I naught? The peak current. And what's the peak current? What we have beside what? The sine. So this is our peak. So it means our IDC equals to 2 over root 2. Finish. If you rationalize, multiply this by root 2 over root 2. So at the end, you are going to get what? Our IBC to be root 2 amperes. Next, when an alternating current is given by this, passes through this 12 ohm resistor, the power dissipated is, now, if you are given resistance of a resistor, the power dissipated straight is equals to what? If you are given the current, that is I squared R. So we are given R to be 12, and this look for I. But note, this I is IRMS. I mentioned that during the lecture. So this 10 here we have is peak current. So the peak value of the current is the coefficient of the sign, which is what? 10 amperes. So you have to look for the I, which is IRMS, which is I naught over root 2. So it means our I equals to, what's I naught? 10 over root 2. So we cannot come here and say our pi equals to I squared. And our I is not 10 over root 2. That will be 10 over root 2 all squared times what's R? 12. So P becomes square 100, square 10 100, square root 2 is 2 times 12. 2 in 12, 6. 6 times 100, 600. So it means the power is what? 600 watts. Next one. The energy stored in an inductor of inductance 15 millihenry. Inductance is what? 15 millihenry. But note, milli is what? 10 to the power of minus 3. So when a current of 6 amperes, so we are given I to 6 amperes, flows through it is, then you are looking for energy. Recall during lecture I told you, for an inductor, the energy is what? Half Li squared. In this case, we have only one inductor. If you have more than one inductor, if they are in series, you add. If they are in parallel, you treat them like parallel arrangement of what? Resistors. So from here, you can get our E, which is half. The L is what? 15 millihenry. So that's 15. What's milli? 10 to what? Negative or 3. Then times I squared times 6 squared. So 6 squared 36. 2 36 18. So 18 times 15 will give you what? Yes, 270. This 3 minus 3 is 17 as 1 by 1000. So 270 over 1000 will give us what? 0.27 joules. So it means the energy is what? 0.27 joules. Next question. An AC circuit of EMF 12 volts has a resistor of 8 ohms connected in series to an inductor of reactance 16 ohms and capacitor of capacitor what? In short, we are given V to be 12 volts. We are given R to be 8 ohms. We are given, this is what? XL straight. Note, this one is not inductance. We are given what? Reactance. Inductive reactance. So that's ohms. Assuming we are given inductance, that will be L. So you have to go and get XL, which is what? 2 pi Fn. So in that case, they will give us frequency. But they made the question easy already. We are given the inductive reactance as 16 ohms. And capacitive reactance, that's what? XC, as what? 10 ohms. First, in any circuit, V is IZ. So if you are looking for I, the current equals to V over Z. We are given V to be 12, so the only thing is supposed to get Z. What is the impedance? Square root of R squared plus XL minus XC squared. Is there your notes? Z becomes what? Square root of, what is R? 8 squared plus XL is 16, XC is 10. So 16 minus 10 is what? 6, that's 6 squared. So if you continue, you get Z to equals to square root of 64 3600. Then Z equals to 10 ohms. Our aim is to get I, and I equals to V over Z. V is what? 12. Z is what? 10. So the current equals to 1.2 amperes. As simple as that. Next question. Given that the PD or EMF is given as this AC EMF, the instantaneous value of the EMF 1/4 of the period is, this is very simple. You can even draw it from the graph. Let's show that on the graph. So let's suppose this is the waveform. So this is E against time. So the maximum current, the maximum value of E is E naught. So this is maximum current, the maximum EMF. So we are now looking for the instantaneous EMF. EMF at any point in time on this graph is all called instantaneous. But it told us 1/4 of the period is, what is 1/4 of a period? You If you move from here and you end there, that's a period. From here to here, this is a period. From here to here, this is half a period. From here to this is what? Quarter of a period. So this is what? Quarter of a period. That's T over 4. So at this point, what is the value of EMF? EMF equals what? E naught. So the answer is that the EMF is what? E naught, straight. In the option, you have E naught, you have E naught over 2, you have E naught over 4, and the likes. Don't disturb yourself, the answer is E naught. Although we can solve that actually. We can solve it. How? Quarter of the period, from there we can look for the frequency. And if you include the frequency here, you can multiply R and divide. But that will be too long. You also graph and get the answer straight. For the next, in the diagram, find V. V. So we have inductor, capacitor, resistor, and we are given the PD across each. So it's as though we are given VR, we are given VL, we are given VC. What is V? Remember the formula. V equals to square root of what? VR squared plus VL minus VC all squared. As simple as that. Impute and get the answer. The VR is given to be 80 squared. What is VL? 40. What is VC? 110. From here, we get our V to the square root of 80 squared plus 40 minus 110 should give us 70. So that will be, and if you square negative, it cancels. So it doesn't matter whether you do 40 minus 110 or 110 minus 40. That's plus 70 squared. You can finish that by yourself. Next, in an AC circuit, the ratio of the RMS value to peak value of the current is RMS to peak. Recall that IRMS equals to what? Peak value over root 2. So you're now looking for RMS, ratio of RMS value to peak value, meaning we want I naught to be here. So from here, if we cross multiply, we are going to get that what? IRMS equals root 2 equals to I naught. And what we desire is the ratio of IRMS to I peak. So IRMS to I peak. So divide by I peak. So it means from here we can say IRMS to what? I peak. This cancels this times root 2 equals to 1. To be able to get this one, we divide by root 2 over root 2 over root 2. Cancel. The answer is 1 over root 2. If we rationalize, we are going to get root 2 over 2. That's the answer. Lastly, when a certain AC supply is connected to a lamp, it lights with the same brightness as it does with what? 12 volt battery. A battery gives DC. So this 12 volt is actually what? VDC. So we are told that VDC is what? 12 volts. Now ask, the RMS value of the AC supply is what? We are looking for VRMS. Most people just do 12 barrels too. No, don't mistake it. When I started lecture, remember I told you that VRMS equals to VDC. So just equate both. Since VDC is 12, it means VRMS equals what? 12 volts. Don't do that mistake. VDC equals to VRMS, IDC equals IRMS. And these are jam questions, as you can see, they are very cheap. So perhaps when we solve Y question, we can have some fun, because when questions are too simple, you might not enjoy it. See you in my next class. So this marks the end of electric field. Then next we are moving to magnetic field.